In the previous class, we defined oxidation as gain of oxygen and reduction as loss of oxygen. And we said redox means reduction in oxidation. I gave two or up to four examples of reaction that involves gaining and losing of oxygen. So to have a quick recap, CuO, copper 2 oxide, plus hydrogen will give us copper plus water. So this is reduction because copper 2 oxide loses oxygen to become copper. This is reduction, while hydrogen gains oxygen. This is oxidation. So this is not the only way we can define redox reaction. We can also define redox reaction in terms of electron transfer. In fact, that's the broad definition of redox reaction. So today we want to talk about redox and electron transfer. Redox and electron transfer. So I will use those examples we used the other time so we can understand how electron is moving from one reactant to another reactant, or how it's moved from a reactant to become to form product. So I will take burning of magnesium again. Mg, magnesium, react with oxygen to form magnesium oxide. So now we want to explain this in terms of electron transfer. So we look at it from the side of metal and non-metal. That's the easiest way. So remember, have this behind your mind, that metals to ion. So when metal goes to ion, metal loses electron, loss of electrons. When metals, whenever they go to ions, for non-metals to become ions, they have to gain electron, gain of electron. And our representative metal here is magnesium. Let's see how magnesium and oxygen come together to give magnesium oxide. Of course, we've done something like this in chemical bonding. So this is an example of ionic bonding. So it is like this. Magnesium is element number 12 in the periodic table. So it means if you want to draw the electron shell for magnesium is like this. Mg, the first shell, that is, if you want to arrange the second shell in the third shell. So this arrangement is like 2 8 2. I hope you will remember that. So the first shell will the first shell carries 2 electrons. Let me use a better one. The second one carries 8 electrons. It carries 8 electrons, while the last shell is carrying just the remaining 2 electrons. Okay, something like that. Okay. Now, remember, for atoms to attain octet, that is to be stable, just like group 8 element, they have to either share electron or they transfer electron. So remember, we're talking about formation of magnesium oxide. How can magnesium react with oxygen to form magnesium oxide? So we want to see what happened between them. So this is magnesium, and let's draw for oxygen. Oxygen is element number 8, so it has 8 electrons. So it means it's going to have 2 shells. Don't mind my shell, please. So the first one carries 2 electrons. The second shell carries the remaining 6 electrons. 1, 2, 3, 4, 5, 6 to be easier that way. Okay, so for magnesium to be octet, that is to have this last shell, the shell, to have the last shell to be 8, this last shell to be 8, to carry 8 electrons, magnesium has to throw away these 2 electrons. So throwing away means it will lose this electron to a substance. So it lost this electron to oxygen. So oxygen has new electrons here now, which is from magnesium. And it lost the second electron because oxygen has two spaces to get electrons, and when those electrons, when they come, you will see that oxygen will have a very nice life. If you count number of electrons here, it will become 8. So oxygen will change from 2, 6 and become 2, 8. Magnesium changes from 282, changes from 282 to become 2, 8. So 2, 8, 2, 8 for both of them. So it means they can be stable now. So at the end of the day, we'll have something like this. We have magnesium with remaining 2 shells, Mg, the first shell and the second shell, 1, 2, and let me draw it clearly or clearer. I take these shells. If I can take them, only this inner shell. Okay. Okay, the inner shell. So I think I'm losing 2 electrons. So let me put them. 1, 2, and this one 2, 1, 2. Yeah. So we have this left for magnesium. Because it has lost 2 electrons, we must show that this is magnesium without 2 electrons. How can we show that? We are going to put +2 here. But why is this one +2? That's another question. Why is this? I say +2. I think it's better we say 2+. This is normal convention. 2+. So why is this 2+? Remember, magnesium here has on top here, it has 12 protons and 12 electrons. So everything will be 0 when we add them together. But here it has lost 2 electrons. Remember, number of protons cannot change, so it will still have 12 protons, but now with only 10 electrons left. Plus means proton, negative means electrons. So we have 10 electrons left because it has already lost 2 electrons to oxygen up here. So at the end of the day, when we add this together, we will have +2. We will have +2, and that is why we have this. So whenever an atom loses electron, the number of proton will raise by the amount of electron lost. So it will be +2. It's like it has just like it has 2 extra proton, although it does not have 2 extra proton because electron has been reduced by 2. So that's what this 2+ mean. Okay, so if we go to the side of oxygen, so I will take this directly. Again, take this. Okay, and I'll bring it down here. Okay, so this is our oxygen here. Okay, so this will also be, let me fill this one up. Okay, I think it's okay this one. So this for oxygen. Now you can see these two extra electrons here. This is very easy to indicate here because it's having two extra electrons, so we can just say two extra electrons. Two extra electrons. So now we can summarize this process, or before we do that summary, this is magnesium, Mg2 plus and O2 minus. So this charge will cancel this charge. At the end of the day, we have MgO. But that's not where we are going actually. Where we are going is this. If you look up here, we can see that there is transfer of electron from magnesium to oxygen. So we can say magnesium loses electrons. Magnesium loses electron. It loses electrons. Why we will say oxygen gains electrons. So now we want to talk about oxidation now and reduction. Whenever a substance loses electron, that substance is oxidized. That substance has undergo oxidation. So we will say magnesium is oxidized, or we say this process is oxidation. So loss of electron is oxidation. Why gain of electron is reduction. So loss of electron is oxidation, gain of electron is reduction. So we have something to remember that, and that is oil rig. Oil rig. That's where the well where they get oil, crude oil. Oil means oxidation is loss of electron. Reduction is gain of electron. So oxidation is loss of what? Loss of electron. Reduction is gain of what? Of electron. So let's compare this to transfer of oxygen, so we can also remember that. Of course, we know that oxidation is gain of oxygen, so the opposite would be for electron. That one is also easy. It's another easy way to understand it. Oxidation is is gain of oxygen, but oxidation is loss of electron. So we can also say reduction is loss of oxygen, and at the same time say reduction is gain of electron. It's a gain of electron. To gain oxygen, you have to lose electron. It's very simple. For magnesium to gain oxygen, it has to lose electron. So it's like you want to get married. Magnesium want to get married to oxygen, so it has to give out dowry. So dowry is electron. So it lost electron to gain oxygen. So you can see it that way as well. So we'll see more of that. We have more examples of that later, inshallah.